Okay, there's let's let that load up here. There's a couple things here. There's this new equation. I call it PAT, P-A-T, and there's two possibilities for growth. For growth, A is 1 plus R. For decay, it's 1 minus R. So in this case, because it's decreasing, it is decay.
Yeah.
So it starts with 3,900, 1 minus 0.0325 to the power of t, or in this case, 15.
15, that's time. Yeah.
And you go right to your calculator. Calculator will do all of that if you needed to. 25. And then we're rounding to nearest square kilometer to the nearest ones place. I've got 2,376 for that.
Let me check it on my. I just used the embedded Alex calculator. They like if we use that also. Yeah, I got the same thing. Okay. Okay, I'll share my screen, then I can probably attempt this one. Continue. So principles. Oh, I think I get stuck when it says like compounded annually, because then I don't know what to put.
This one is it's the same as the previous one, but just in the context of money. So since it grows, and I'll snip it into the other screen, but since it grows, it's going to be 1 plus R here. But let me go ahead and so your PAT here, your PAT is 1,700. Your A is 1 plus 0.085. So it's 1 plus R because it's growing to the power of 7.
Oh, okay.
Now, maybe what you're thinking of is when it's not compounded annually, which is compounded quarterly or weekly or so on.
Okay. Yeah.
To the power of, and round to the nearest dollar. So I get 3,009 in this case.
Okay, I think I'm doing something wrong on my calculator.
If you want, you can share your screen. I can take a look at what you're doing and see if I can help.
Yeah, because they recommend, they'd like tell us to use the Alex calculator.
Yeah, so let's just type in 1,700 parentheses 1 plus, and then if you don't like converting, you can type 8.5. Okay, so there we go. That's the problem. You're typing in 0.85. If go ahead and just type in 8.5 without the decimal. And like then 8.5, and then divide by 100. So put slash 100. So what that does is it converts it to a decimal. So you don't have to try to think about how to do it. Go to the right there and put a parentheses in. And then to the power of 7. Oh, no E.
Yeah.
There it is. That's maybe there. Okay.
Then this
there it is.
Okay, got it.
Yes.
Okay, perfect. Okay.
All right, so why don't you try this one? I just need to grab my copy from the microwave. I'll be right back.
Yeah, I could do that.
Okay, this looks good.
And then that would round.
Okay, so
to-
just real quick on, so
Mhm.
that x to the y there, do you see that above the 8? That's the better one for the exponent. If you go down to, instead of using e to the x, see where there's an x to the y above the 8?
X.
Above 8, go left.
Oh yeah,
left.
right here.
That's your exponent.
Okay, so I
That
should
might-
use this one.
Yeah, instead of the e to the x, that'll save you a little. Yeah, so that round to the nearest whole number, 528,092, it looks like.
2, yeah. Two. Okay. Okay. Yeah, I guess we can just start with this one. Okay.
All right, I'll grab a snip and we'll work this out together. All right, new share. All right, compound annually. Okay, so the equation here, it's kind of like what we've been using. It's but I'll just make it more generalized, I guess. So the future amount is the amount you're starting with, 1 plus r divided by n to the n times t power. Okay, so this looks maybe a little bit overwhelming, but because it's computed annually, n equals 1. So it really simplifies this. It becomes 1 plus r to the power of t. And your r is the 5.75. So in your calculator there, just like we did before, you're going to divide by 100.
Okay.
Okay. The amount you're starting with is 2,000.
Right.
Okay. And you're trying to get to 3,000.
3,000. Okay.
Like that.
Okay.
To the power of t. Okay. Now this is where the logarithms come into play. But is this okay? Is this setup okay?
Yeah, yeah.
Right.
This is familiar. Yeah.
All right, so we're going to divide both sides by 2,000. So it becomes 3 over 2, or 1.5, equals, now the part inside parentheses is going to be 1.0575 to the power of t. That's just simplifying inside there. This is now where you're going to use logarithms. So we're going to use natural log in this problem.
Right.
Natural log of 3/2 equals natural log 1.0575 to the power of t. There's a property of logarithms that allows this t to come out in front. Very super important to do that. Natural log of 3/2 equals t. Natural log 1.0575. You're going to divide both sides by the natural log 1.0575. Okay. And so the t is from the calculator 3/2 natural log 1.0575.
And then that's what I'm going to plug into the calculator.
Yep. And I'm going to do that as well. Hopefully this works out nicely. It says to the nearest percentage. So I'm guessing it's be really close to like 2 or 3 or 4. And actually it's not that close, but.
So I got 7.25.
Yeah, and that's, I mean, I was thinking it would be like 7.0 or something, but it's 7. So your answer here is 7. So please try that.
That said, yeah, incorrect.
Okay.
So it's
where did I go wrong? So the like what I'm bothered by is the fact that like it didn't work out nicely, but because it has to have $3,000 or more, like it's not going to have $3,000 if it's 7. It will if it's 8. So do you mind trying 8 and seeing if that takes, if it takes that, meaning you got to go up to the next year?
Yeah. Okay, it did take 8.
Okay, so there's something. There's the way this problem is written, you have to round to the next year.
Next year. Okay. Okay, I'll make note of that. Okay, I'll share the next one. Okay.
Okay, so here's another one to do that's like the previous one. I'll grab a snip here and we'll show you the steps in screen. There it is. Okay. After so the loan of 50,000 is made at 3.75%. After how many years will the amount due reach 66,000 or more? So that or more again tells us we have to at least get to that. We'll probably end up rounding up.
Yeah.
So the principal is 50,000. 1 plus 3.75 divided by 100 to the power of t, which we don't know, and this will eventually equal 66,000
right.
or more. Divide both sides by 50,000. So I'm gonna write 66 over 50, just canceling out the zeros. Because we're going to the calculator, I don't want to do it quite yet, but you could put that in the calculator right away. 1.0375 to the power of t. This is where you have to use ln, or natural logarithms. So natural log 66 over 50 equals natural log 1.0375 to the power of t. This allows that number to come in front like that. The natural log property. So we got natural log 66 over 50 equals t, natural log 1.0375. You divide both sides by the natural log of 1.0375. It is a number. It's just not a friendly number. It's just a So your t, just like the previous problem, you start seeing these patterns of what the results are.
Right.
So give that a try. We will be rounding up to the next decimal place.
Yeah, I also got that 7.54 so to 8. Okay, perfect. Okay, I can attempt the next one and I'll share like my screen again.
Sounds good.
Okay, I can.
This one's different, of course. So
oh, okay. Yeah.
Let me grab it here and
oh, okay.
All right, here we go. I'll set it up here and let you work it out from the setup. But the difference here is that its value is going down. It's reducing.
Which is like 200. Yeah. But
so you're starting out with 1,700, but your A or your number inside here, it's gonna be 1 minus 75 over 100 instead of, because it's going down to the value of t, and then this time you want it to be 200. So go ahead and try working this out from here. If you have questions, please ask, but it does work out very similarly.
For the decimal, is it 0.25 when you?
Yes.
Yeah. Okay, just making sure. Okay, I got 1.54.
Yes.
So
Okay.
that
Now,
would
just like last problem, you have to adjust that.
I guess that 2.
Yes.
Okay, got it.
Wait a second here. That's sorry, that isn't right.
Oh, okay.
Because that doesn't intuitively make sense. Sorry. So the value, the way we just did this is it would be the 25% each year. And so the mistake here is that this number inside parentheses is, there's two ways to do it. It is 0.75 in parentheses. And the mistake here is that I should have said 1 minus 25 over 100. Because 2 doesn't make any sense. In 2 years, it's not going to be down to $200 or less. It's not long enough. So the mistake there, I don't know if you can quickly change that, but it ends up being that this ends up being 2 over 17 equals 0.75 to the power of t. T ends up being the natural log of 2 over 17 over the natural log of 0.75. Not 0.2. I'm sorry.
Yeah, I see that.
And again, it ends up being 7.44-ish, which goes to 8 yet again.
Right. I got it. Okay, I'll share my screen again. Yeah, this one I got stuck on.
All right, let me try to think how we're going to do this.
I usually like write it out because I know I use the values of like -2, -1, 0, 1, 2. And then I'll write it each in a line, like how to do the math. And then I just write the points, like my final points, and I'll plug it in through this.
That sounds good. So let me, I will give you some notes here for this first one. Okay, that's loading up there. So there, the asymptote here, because this is an exponential function, they either look like this or look like this. The asymptote is whatever number is being added to this, which is nothing, but it is y equals 0. So you want to get that horizontal line there at that first one. Now you're right. You come up with 5 points. Do you have a calculator on this one or not?
Yeah, but I also just
So we want to choose nice points. So a nice point is 0 typically, and that's minus parentheses 4 over 5 to the power of 0. Good opportunity to actually use that calculator if you want, but anything to the 0 power is 1, but then you negate it. The other nice point that's typically good to use is 1. So this is -4/5 to the power of 1. You first apply the exponent, so it becomes 4/5, then you negate it. -4/5. And then I guess I would do 2. So it's negative parentheses 4 over 5 to the power of 2. If you enter it exactly the way I have here in the calculator, it will give you the result, although it might give you a decimal, not a fraction.
Yeah. I'm actually not using a calculator. I usually just hand do it.
Okay.
Yeah.
So this is the going this direction is usually okay. It's going the other direction that's not as okay. So we'll do that now.
Yeah.
This means negative parentheses 4 over 5 to the -1 power. That means you first flip what's inside.
Flip it. Yeah.
So it becomes -5/4 to the power of 1.
1, right.
No change to that, but it is negated, so it's -5/4.
4, okay.
Then for -2, it's -4/5 to the power of -2.
Mm-hmm.
The negative exponent again flips what's inside. So just do one thing at a time.
Mm-hmm.
Then you have a square, so it's 25/16, but then it's negated.
It's not negative.
So from my experience, the biggest one, headache here is entering all these points and the asymptote.
Yeah.
Just do it, nice and slow.
Okay.
You need me to watch. You could also go to Desmos.
Yeah, I know it.
If you need a guide when I'm not around, but it doesn't give you the decimal, or it doesn't give you the fractions. It gives you decimals.
Yeah, I was actually working. There was like another topic like this that I understood, so that was like easy. I think it just when the negative was implemented, I was like doing it backwards, so it was graphed like the other way. Like yes. I had made some mistake there.
It's the negative comes last,
yeah. Okay, I'm plugging those in, so I'll share my screen. Wait, I think that doesn't look correct at this point.
No, there's a mistake there.
Yeah, wait, 2.
It should be -16/25.
Oh, I see what I didn't have this. Like that. Okay. And then this is where I'd put the.
Yep, that looks good.
And then,
yeah, that looks good.
Looks right. Yeah. Okay, I know I can do the other two after this. That's right where I just got stuck on. Yeah, I wanted to work on a different one. Yeah, why not? Let's just do this one. That looks okay. Yeah, that actually looks pretty easy. I know I can do that. More graphing. Okay, I guess these ones are kind of tricky. Start it. Okay.
All right, let me grab they did you no favors on this first. Okay, so the log ones, boy, this is always tough to explain. So it might take a few to get this down. That you can only take the log of certain numbers. Okay, now one of the things that you can always do, the log base b of 1 is always 0. It doesn't matter what the base is.
Right.
1/2 in this case could be a billion, pi, whatever. If it's 1, you always get 0. So that's a great starting point. The next numbers you choose are based on the base. It's based on 1/2 to the power of 1, or 1/2 to the power of 2, or going the other direction, which will apply here, 1/2 to the -1, 1/2 to the -2.
Right.
Okay. And I don't know how comfortable you are with these, but that is, you do have to be able to calculate these numbers. This is 2. And this last one is 4. So these are your x values. So we're gonna we've got this. Actually should go a little further down, or actually that was fine right there. Okay, so we've got 1/4, 1/2, 2, and 4 for your x values. Okay, so let's let's start with this 1/4. While it is log of 1/2, base 1/2 of 1/4, it's better to look at this as log of 1/2, 1/2 to the power of 2. Basically, instead of the 1/4, look at it as this thing here. Because when the bases are the same, That's another property. Log base b of b to the x, it just equals x. Since this 1/2 equals this 1/2, the output is just this number here too.
Right.
Same thing with the next x value. So it's log of 1/2 of 1/2. There is a little exponent of 1 there. That tells you that it is 1.
1, yeah.
So the next one here is 2, log 1/2 of 2. Again, 2, you go back to your table here and they're like, okay, 2 is really 1/2 to the -1. This is really log 1/2 of 1/2 to the -1 power, which tells you the answer is the exponent. Same thing with the 4. So what you really want each time is the base to equal the thing you're taking the log of. 4 is really 1/2 to the -2. Log base 1/2 to the -2 power becomes -2.
Okay. Okay. Yeah, that is a little bit, but like I kind of see it. Yeah.
The asymptote here. This is another thing. You set the part inside parentheses equal to 0. So in this case, it's just x equals 0, which is a vertical line.
The asymptote, yeah.
But if it were like x minus 1, it would be at x equals 1. This one ends up looking like this when you get a graph on the right there.
Yeah, so it looks like that. Okay.
You got a very difficult one to start. Usually it's like if you hit next, you'll probably get like log base 3 or something. Yeah, something a little easier. But would you like us to do another one here?
Yeah.
Okay. All right, so you make a table here again, x, y. The one that really always seems to work is 1. Log base 2 of 1 will be 0. But because you're adding 4 to it, you have to add 4 to your answer. So that's why it's 4 plus 0, which is 4.
4.
Okay. All right, so that's great. You're like, okay, I got 1 point, but you need 5. Oh no, I'm sorry. Plot 2 points. I'm sorry. I didn't mean to. Now that's actually better.
That's easier, yeah, shorter.
So we're going to use 2. So you always pick 1, and then 2 is the one that matches here. So 4 plus log base 2 of 2. There's really a 1 there because those are the same. It's just the 1. This becomes 4 plus 1, which is 5. Now the asymptote comes from that x. You set that x equal to 0. It's a vertical line through that.
Okay, I'll just share my screen just to make sure for it to look like this.
Yeah, that looks good.
Yeah. Okay, I wonder if this one will be different. Oh, yeah, could you also do this one? Because
sure. Yep.
Yeah. Just so I had like notes on 3 different styles of graphing.
Yeah, the ones where the base is a fraction are always harder, more frustrating. Now I made this overly complicated, and I realized I didn't look closely enough. It says 2 points. So the first point you should always choose is 1, because 3 log base 1/3, or really any log of 1, is always that part is always 0. 3 times 0 is 0. That's
0.
Yeah,
just known. Yeah.
The next point is to match the base. So in this case, it'll be 1/3. 3 log 1/3 of 1/3. because the base matches the part you're taking the log of, that's 1.
1.
3 times 1 is
3.
3.
Yeah. Okay, got it. Okay, that's actually pretty simple. But yeah, usually it asks for 5 points. So I also wasn't paying attention because I thought it was asking for 5 points as usual.
Usually they want a lot and you're just like shaking your head. We know
Yeah.
why.
Yeah. Let's see, wait. It's saying here, I'm just gonna share my screen. I don't know what happened. It's saying to plot.
You also need the vertical
asymptote. Yeah, so I have to put this first.
That's me at 0 there.
There we go. Yeah. Okay. That makes sense. Okay, yeah, I did also get kind of stuck on these graphing ones.
All right.
Yeah.
This one's got the added domain and range.
Right.
So, which talk about. All right, that's loading up there.
Okay, I see it.
All right, the domain is always all real numbers. Always. For exponential functions, it's a note card equivalent. They're always true. The range is based on 2 things. It's based on this number here, and it depends on whether the thing opens up, goes up or comes up to it. Basically, it's either 3 to infinity as it is here, or like if there were a negative in front, it would be going there. But we'll also see that from the graph. So the range you can actually maybe get better from the graph. So we'll just look at that when we're done here with some points. Okay. But there's kind of like ways to do these without actually you don't have to be very sophisticated about it. So now to do this, how many points does it want? 2 points and the asymptote. Okay, let's start with the asymptote. It's y equals 3 because of that 3 there. So you need a little. Yep. And that's what I was mentioning. It's either going to like approach that from the bottom or from the top. We'll see here in a moment. All right, so it's 1/4 to the power of x plus 3. So in terms of your table, I recommend always doing 0 because anything to the 0 power is 1. So that would be 1/4 to the power of 0 plus 3. 1 plus 3 is 4. The next one, it is up to you. I would do -1 here because anything to the -1 power flips the fraction.
Right.
But if you're not comfortable with that, like it's okay if you don't want to use it and you want to use like 1, you just end up getting a fraction as your answer. This ends up being 4/1 plus 3 or 4 plus 3, which is 7. So -1, 7, 0, 4. So you'll see that it looks like this now when you graph it, and that supports the range. The range is the smallest value, which is 3. It approaches 3. How high up does it go? It goes to positive infinity.
Yeah. Got it. Okay, got it. Okay, I'll share my screen again, and then I'll also attempt like this. Yeah, so we know domain is always going to be negative infinity to positive. And then here, this is -1. So it'll be -1 to positive infinity.
Okay, well, we'll confirm that with the graph later on.
Right.
Can you draw the horizontal asymptote now? Because you just said what it approaches, which is that -1 value.
So it's -1.
Good.
Yeah.
Okay. So this is perhaps the hardest part, is to put 2 values in to the equation. I would recommend trying 0. So it'd be negative 1/3 to the power of 0, which
Mhm.
is
1 minus 1
so the 1/3 of the 0 is 1, but then you
is
negate it.
1.
It's actually negative 1 minus 1.
Minus 1, which is negative 2.
Yes. So when x is 0,
Mhm.
y is negative 2.
Mhm.
And then I would put negative 1 in for x because that
Mhm.
will flip the fraction inside, making it 3.
Mhm. Mhm.
But then you negate it.
So that'd be negative 3 minus 1,
Yes.
which is
Negative 4.
4. So we have
So when you plot those 2 points, you will see that you'll want to make a small adjustment to your range, but I'll wait till you plot those to see that. Okay, so go ahead and connect the points there. So your range says it goes from -1 to infinity, indicating it would be above that line.
which is not true.
That's not true. So you want to go back to, okay, it actually starts all the way at minus infinity and goes up to minus 1.
1.
Okay, that looks pretty good.
Okay, I'll try this one again. Okay, so I guess I'll save the range for after I plot it.
Okay, that's
Yeah.
okay to do.
That. Okay. And this one. So even in this case, let's plot 2 points. I could just do like 0 for x or 1.
Draw your horizontal asymptote first, but yeah, you will want to use 0, but draw the horizontal asymptote, which there's nothing being added to the side.
So it's just 0.
Yes. You also can get the horizontal asymptote after you graph the 2 points because it'll kind of show you where it should be. But now, like you said, put 0 in for x, and then 1's a good number this time because it's positive exponents.
So the first point would be 0, 8. Or
that's right, 0, 8.
So yeah. And then for 1, and then the second one. Wait, what am I doing? Wait, 2. Yeah.
You can do 1. It might be too large, but maybe it'll accept that. Should be 1, comma.
I solved the exponent first, so I got.
You add 3. 1 plus 3, 4. And then it's 2 to the power of 4.
4, which is 32.
Yes.
Or no. Yeah.
No. 2 to the power of 4 is 16.
16.
Yes.
32. So yeah, I don't know if the range if it'll let me graph 16.
Yeah. So you may want to go to -1.
1. Yeah.
And then that becomes -1 plus 3 is 2. Which is 2 to the power of 2 is 4.
Which is 4. Yeah. So then, say if I do plot this is going to be at wait.
Everything's good. It's all good.
So yeah, so for range, I look at is it on the
range is the y values. What's the smallest y value that you like? What does it approach there?
Yeah, I guess Well, it's going to negative infinity.
X is, but the Y value there is 0. And the 0 is also what is being added to the equation, 2x plus 3 plus 0
0. Mm-hmm.
So it's either 0 to infinity or minus infinity to 0. And so you're what you're trying to decide is how far up does it go? What's the biggest Y value?
To 8.
Keeps going. It keeps going.
So for infinity.
Yes.
So it's negative infinity to positive infinity.
No. The smallest Y value is 0. Like it goes left forever, but that's the X. The Y is
positive infinity.
So the range, think of the range as the minimum value to the maximum value. The minimum value
is 0.
Yes. And then the maximum as it goes up to infinity.
So it would look like this.
Yes.
Yeah. Okay. Yeah, I think I get confused. I look at both of like the ends, but it's always going to ask for like what the plus is, like the Y.
Yeah, the domain and range is very complicated for most students, so it just takes a little more practice to get it down.
Okay. Then I'll see if they have any other like, graphing ones. Like domain and range. Okay, I tried working on this, but this might take a second also. Look how this started.
All right, these are an algebraic headache for most students.
Oh gosh.
Yeah. All right, so let me all right, so that's it's loading up there. The only way to get an exponent out or variable out of the exponent is to use natural logarithm. So it's natural log 7 minus 3x equals natural log 17 minus x minus 2. So you're going to use ln. It's always your first step. And then we did this before where you take that exponent and bring it out in front. It was always kind of nice. Treat the exponent as if it's in parentheses, especially when there's two terms. So on the left, it doesn't matter as much. It's minus 3x natural log 7. But on the right here, it is minus x minus 2 natural log of 17. Please make sure you're okay with what is there.
Yeah, that makes sense. That's easy.
Okay, now we're going to distribute the natural log of 17 to both of these. So this becomes minus x natural log 17 minus 2 natural log 17. Okay, now we want to get all x terms
to one side.
On one side. So in this case, I'm going to add x natural log of 17. You could move the 3x minus 3x over. There's options here. But this is my preference here. So it's x natural log 17 minus 3x natural log of 7 equals negative 2 natural log of 17.
Got it. Okay.
Now you're going to factor out x on the left. So it becomes natural log 17 minus 3 natural log 7 equals minus 2 natural log 17, like that.
Got it.
Divide both sides by the natural log 17 minus 3 natural log of 7. And that is your final answer. Now, word of caution, the online calculators won't give it to you in a form that it wants you to write it this way, I believe. I think if you try to go out and just solve it, it doesn't give you this, it like combines these. So let me know if you have any issues entering this.
Yeah. So, okay, yeah.
but the steps are always the same. It's always take the natural
Yeah,
log,
yeah.
multiply.
Yeah, I didn't find that too tricky. That actually
Okay.
is pretty simple. Yeah.
I like hearing that.
Yeah, that was. So, let's see. Yeah, I'll just like share my screen. I think this looks okay. But yeah, I'll see if it takes it.
Is there a negative somewhere in the numerator? Should be -2. Natural log 17.
I think so. Like that.
That looks good.
But yeah. Okay. Okay, I'll attempt this one.
Okay.
Yeah, these do take a little longer, but and then I'm gonna see this. Okay, I think I got stuck on one step. I have it written as -3x ln 12 equals x minus 4 ln 11.
Yeah. Okay. Let me quickly share here, and I've got it worked out. But you can
see this stuff. Okay, so that's there, and then okay.
so you have to multiply them both.
Both, and then
I moved this one over to the left.
Oh, okay, that's where I stumbled. Right. Okay, yeah. Okay, yeah. Got it.
All right. Well, unfortunately, we do have to stop here. I know this is so much fun, but